Alright, so we're going to compute, I'm going to illustrate Bayes' theorem using this example. Suppose that visitors to the site are classified into two classes. Make purchase of $500 or more, make a purchase of less than 500, then make no purchase. Okay, so and an examination of the records. Okay, so let's define these classes. So the first one is make purchase of $500 or more. Make purchase of less than 500. Okay, and then make no purchase. So an examination of the record of customers' behavior revealed that those who made the purchase of $500 or more, 70% spent at least 15 minutes. So here our intervening event, okay, is V, visitors spent at least 15 minutes. Okay. So from this statement here, our prior probabilities, called marginal probabilities, 0.15, 0.2, and 0.61. Then the conditional probabilities are given here. An examination of the records show that those who spent $500 or more, so that is the given event is B sub 1. Given that they spent $500 or more, 70% of them spent, so 0.7 is the conditional probability here, V. What is the probability a customer spent 15 minutes or more, given that customer bought stuff worth $500 or more? And then 80% of those who didn't make, well, less than 500 was 80%, so this is 80%, and those who did not make a purchase, 50% of them. Okay. Now, our objective is to find posterior probabilities. So given that customers spent 15 minutes or more, okay, so now what is the probability that the customer will make a purchase of whatever, 500 or more or less than 500, or not make a purchase? So prior probabilities of the class of these, and the prior probabilities must sum to 1. Okay, so that's how it will be collectively exhaustive. Okay, so when you sum this, it should be equal to 1. If it is not 1, then that it is not collectively exhaustive. Okay. And of course, they must be mutually exclusive as well. And the conditional probabilities are these. Okay. So once you assemble these two columns, the rest is pretty mechanical. Okay, rest is very easy. So all you have to do, in fact, the joint probability is the product of that times that, right? And then you add these, that will give you the probability. So sum of that, right? Sum, that will give you the probability for V. So this is probability of V V is that. Then all you have to do is just divide it back in and you get the posterior probabilities. So that divided by that. Okay, that has to be the that should be E91 must be absolute reference, so we can copy it. So that would be the posterior probability, and that again should sum to 1. So that should sum to 1. So our objective, okay, the posterior probabilities are